There it is, a Sedco rig, one of the best. Good equipment, hard-working men, men who know their business. If you're a Sedco man, then you take pride in your rig, and you do your best to make it run safely and efficiently. If you're a driller or tool pusher, or plan to be one, then you take a special pride in the way things run. Pride even in your equipment, like how much service you get from it. It makes you feel good to know you're keeping costs down. Take that drilling line. If you didn't use and care for it properly, it could be the third largest expense item in the rig, exceeded only by salaries and expendable pump parts. This is where a good drilling line slipping and cutting program comes in. In this program, we'll examine the steps toward the right drilling line cutoff program for your rig. Why you slip and cut the line, how to determine slip and cut lengths, and how to determine the amount of drilling line service you should get between cutoffs. We'll also explain safety factor and how it affects your cutoff program. Safety factor comes into play in some of your calculations, so let's take a look at it first. Safety, or design factor, is a built-in margin of safety in drilling line. It's used as a guideline to keep us from loading the line so much that it could possibly be damaged or even break. In your job, you'll be concerned with safety factors ranging from 2 to 7. 2 being a very low, undesirable safety factor, and 7 being more than enough safety margin. You're allowed to operate with a safety factor of 2 only under extreme or emergency conditions. The standard operating safety factor is 5. Safety factor is actually the ratio of the breaking strength of the line to the hook load. Since stringing more lines allows a greater hook load, the string up figures into your calculations. There's a handy reference chart in the drilling manual that gives the safety factor for any given string up and hook load using standard 6x19 IWRC wire rope. There are 2 reasons to concern yourself with safety factor. 1, when you're lifting a heavy load or pulling on stuck pipe, you've got to know when to stop and string up more lines. 2, when you're designing your cutoff program, one of the ways in which you'll tailor it to your operation is by considering the safety factor at which you normally operate. We'll get into this later. Safety factor should always be kept in mind, but remember, watching safety factor alone won't do you much good without a comprehensive slipping and cutoff program.
In the early days, we discovered that while the line would wear out rapidly at the hoist and drum and the fast line sheaves, it wouldn't wear out nearly as fast between the dead line sheave and the anchor. Well, we wanted to make the drilling line last longer, so between wells, we'd stretch the line out across the field and then reverse it, winding what had been on the dead end onto the hoist and drum first. Of course, by dragging the line across the field didn't help it any, but by swapping ends, we'd get a little more life from the line. We never could figure out how to wear the line in the middle.
Today we use special slide rules and tables and, keeping accurate records, slip and cut the drilling line in such a way that we distribute the wear along the line much more evenly. It all starts here, on the drill floor, the drawworks, the blocks, and at the driller's console, where you're keeping track of the work done by your drilling line. No doubt you're aware of the fact that the work done by the line is measured in ton miles. If you're not familiar with ton miles, stop here and watch parts 1 and 2 of the Drilling Line Care and Maintenance Series. They'll provide you with the background needed to understand this program. Your record of ton miles of service on a drilling line is used in a program of slipping and cutting. After so many ton miles of service, you slip the line, taking some old line out of service and putting into service some new line. A record has to be kept of all the ton miles worked from slip to slip, cut to cut, and from line to line. There are two reasons for this. One, you've got to know when a slip is due to avoid the danger of excessive wear and eventually breaking the line. If you don't slip and cut when you should, you may have to cut off a big chunk of damaged line later. And you're taking a chance that the traveling equipment may come crashing down, possibly hurting or even killing someone. So it's important to keep a record of ton miles so you'll know when slips and cuts are due. The second need for these records is they can be used to determine a need for modification of your slipping and cutoff program to fit the conditions on your rig in a particular area. These tables will give you a starting point for your slipping and cutting program. But based on the big picture you get from your records of ton miles of service per foot, visual inspection of the line, and your goals for wireline service, you'll need to adjust your program to fit the conditions on your rig. Let's look at the reeving system of the rig. The portions of the line marked in red on our model are the critical points where the most wear occurs. Now, these are on top of the crown block sheaves, the bottoms of the sheaves of the traveling block when the traveling block is at the two pickup points, down here, picking up the load coming out of the hole, and up here, picking up the load going into the hole. There are other critical points on the line. At the crossover points, where the line begins a new layer on the drawworks drum, and at the deadline anchor. Now, to slip the line, you'd hang the block on the hang line, release the deadline anchor, and spool some of the old line onto the drawworks. At the same time, feeding new line from the supply reel. In effect, you're moving some of the old line out of service and some of the new line into service. But just as important, you're moving critical points of wear on the line to points of less stress. This evens out the wear along the length of the line, so you get close to maximum wear from every foot of line. That's the key to extending the life of your drilling line. It's important when slipping that you don't move any critical points on the line to new points of stress. You've got a complete set of critical points at each pickup point, so you can't just slip some random length. You have to find a length that moves every critically stressed point of the line to a point of non-critical stress at both pickup points. The right slip or cutoff length for your rig depends largely on the mast or derrick height, because it affects the distance between the critical wear areas on the line. A simple way to figure the cutoff length for your rig is to use this table published by the American Petroleum Institute. You can find the table in the IADC Drilling Manual, a book of ton-mile tables, or on a good ton-mile slide rule like this one. Find your derrick or mast height, follow this line across to the column headed by your drawworks drum diameter. This gives you the number of drum laps per cutoff, and this can easily be converted into feet. Each drum lap is equal to the diameter of the drum times 3.14. For a 142-foot mast and 30-inch drum, the recommended cutoff is 11.5 laps. One lap is 3.14 times 30 inches, which equals 94 inches. 11.5 laps would be about 90 feet. If your policy is to slip 3 or 4 times between cutoffs, then the length you get from the cutoff table should be divided by the number of slips. Using the previous example of 90-foot cutoffs, if your policy is to cut on the third slip, then you should slip 30 feet each time. On the third slip, cut off the 90 feet of old line that's been slipped. Chances are your policy calls for a cut every time you slip. The reasons for this are, it eliminates paperwork and chances of error due to poor communications, and the benefit of slipping 30 feet may be outweighed by the expense of the downtime performing the slip. It's very common now to run a line a little longer, skipping the short slips, and slipping and cutting at the recommended cutoff interval. Instead of halting drilling 3 or 4 times, we stop only once. You know you cut after a certain number of ton miles of service, but you also know that how well a drilling line holds up depends on the hoisting equipment and how it's used. It's like buying a used car. You may have 2 with identical mileage, but one may be a cream puff, while the other is ready for an overhaul. This doesn't mean you shouldn't use ton miles as a guide in your slipping and cutoff program. It does mean you should inspect the line regularly. When you find damage or excessive wear, you should remove that portion of the line from service by immediately slipping and/or cutting that portion of the line. Assuming normal conditions, you'll generally cut the line at regular intervals based on ton mileage. There's a standard method for determining a ballpark figure for ton miles between cutoffs. Because your conditions are unique, the ton mileage you get between cutoffs may be different. The best approach is to start with a standard figure and modify it based on your inspection of the line at the recommended cutoff intervals. Make your observations over a period of time before you go changing your program. An erratic cutoff program has no benefits. There should be a chart like this one on the ton miles slide rule supplied by the wire rope manufacturer. You'll also find the chart in most books of ton mile tables. The same information is contained in these tables in the drilling manual. For this calculation, we can ignore the derrick height figures. What we're concerned with is the diameter of the line and the drilling conditions. This chart was prepared for drilling in the United States, but the same figures will apply all over the world for similar drilling conditions. For instance, if you're in the North Sea, where the drilling is soft and fast, you'll use the figures given for the U.S. Gulf Coast, which has similar conditions. Find your line diameter and follow its horizontal line over to the geographical area that most resembles your drilling conditions. This gives you the number of hundreds of ton miles recommended before your first cutoff on a new line. For subsequent cutoffs, subtract 200 ton miles. The figures on this chart are accurate only if you maintain a safety factor of 5. If you consistently operate at a higher or lower safety factor, you can modify your cutoff figure using the wire rope service curve found in the drilling manual or API Bulletin RP9B. A safety factor of 5 gives you 100% of the ton-mile figure in the cutoff chart. But if you maintain a safety factor of 4, you should expect only 80% of the ton miles on the cutoff chart. 0.8 times the normal cutoff figure. Remember, the figures derived from this chart are merely recommendations. Based on your experience, equipment, and drilling conditions, you may set a slightly different target figure for ton miles between cutoffs. And things like bit chatter, hole deviation, and stuck pipe can occasionally crop up, resulting in excess, unmeasured wear on your line. These conditions may call for temporary changes in your cutoff program. And also keep in mind that visual inspection always supersedes ton-mile goals. Part 1 of the Drilling Line Care and Maintenance series covers the inspection procedure. Revise your cutoff program accordingly if visual inspection at recommended cutoff intervals repeatedly reveals that the line has substantial wear left in it, or if you're constantly having to cut early due to heavy wear on the line. Now we have 2 of the 4 essential ingredients of a good cutoff program: how much to cut and how much service between cuts. In Part 4 of the Drilling Line series, we'll explore the last 2 ingredients: measuring drilling line service and keeping accurate records. Here's a brief summary of what you should have learned in this program. Keep safety factor in mind whenever you're pulling or lifting a lot of weight. To calculate safety factor, multiply the breaking strength of the line by the number of lines strung up, then divide by the weight on the indicator. Remember, the absolute minimum safety factor allowable is 2, and 2 is allowed only during infrequent operations. The lower the safety factor maintained on your rig, the fewer the ton miles you'll get between cutoffs. Drilling line is slipped at regular intervals in order to move the critical points of wear on the line to points of less stress. Cutting is necessary to avoid accumulating too much slipped line on the drawworks and to move the crossover points on the line. It's common practice to cut at every slip, slipping close to 100 feet. The line should be slipped and cut in such a way that no part of the line is shifted from one critical point to another. This means the cutoff lengths should be exact. The cutoff length is dependent on the distance between pickup points, as well as the diameter of the drawworks drum. Use a chart like this one to determine the exact number of feet to cut off. Your equipment and drilling conditions and your safety factor will affect the number of ton miles you can safely expect between cutoffs. Use this chart to estimate the ton miles between cutoffs for your conditions. Keep in mind that visual inspection always supersedes ton mile records. If a line is damaged, you must take the unsafe section of line out of service right away. Try to get into a routine. Adjust your cutoff program only if the need for a change is consistently evident. All the charts and tables you need can be found in one of several sources. This slide rule has just about everything. So do most wire rope suppliers' ton-mile tables. The IADC drilling manual has this information in its section on wire lines, and API Bulletin RP9B is one of the most complete sources available. Take a break now. Have a cup of coffee while you review this material in your workbook. Tests are provided for you to practice and check your knowledge. When you're satisfied that you've mastered the cutoff program, move on to Part 4 of the Drilling Line series, because the story is not yet complete.